Okay, here we go. We're looking at 2015 number 1. Okay, the 2015 free response question number 1. The rate at which rainwater flows into a drain pipe is modeled by the function r, where r of t is given by that equation, and cubic feet per hour t is measured in hours, and t is between 0 and 8. The pipe is partially blocked, allowing water to drain out the other end of the pipe at a rate modeled by d of t, and it gives the equation for that. Cubic feet per hour for t between 0 and 8. There are 30 cubic feet of water in the pipe at time t equals 0. So whenever I come across a problem like this, the first thing that I like to do is I always go ahead and put my equations into the calculator. So if you notice, off to the side here, I have my calculator pulled up, and I've got r of t in y1. So what I'm going to do is I'm going to make a note on my paper that this is y1, just to kind of help me keep track of this. I won't actually write that on my work, but for the sake of my reference, I will label r of t as y1. And then I put in y2 as d of t. So again, I'll make a little note of that on my paper. Okay, just so I can reference that, so I know that I've got them stored in my calculator if I need them. Okay, and everything looks good. Okay, so for part A, how many cubic feet of rainwater flow into the pipe during the 8-hour time interval t between 0 and 8? Whenever you are looking at accumulation like this, we are going to need to use an integral. Okay, so for part A, we're going to use an integral from 0 to 8. Okay, and the reason it's from 0 to 8 is because that's the interval that's given, right? It says from 0 to 8, so that should be pretty straightforward. Okay, it says it wants to know how much water has flown into, how much water flows into the drain pipe during the 8-hour time interval. So there's one of the equations that represents rainwater in, and the rainwater going into the pipe is r of t. So I'm going to take the integral from 0 to 8 of r of t dt. Okay, that's all we got to do for part A. So on my calculator, I go back to the home screen. I go math number 9 from 0 to 8. And remember, we stored r of t as y1. So alpha trace y1 dx, right? And we get 76.570. And this would be cubic feet of water. Okay, I know it doesn't say indicate units, it just wants us to find that number. So we found the number, we're good. Okay, all right. For part B, is the amount of water in the pipe increasing or decreasing at time t equals 3? Give a reason for your answer. Okay, so increasing or decreasing, what do we look at to determine if something is increasing or decreasing? Okay, for part B, what I'm going to do is I'm going to create an equation that represents the total amount of water in the pipe, A of t. Okay, we're going to call that A of t. And this is the amount of water in the pipe. Okay, and so what we'll look at is we will look at the initial amount. So it says initially there are 30 cubic feet of water in the pipe at t equals 0. Okay, so 30. And that's going to change based on how much water has come in and how much water has leaked out. So I'm going to do the integral from 0 to t. The rate that flows in is r of t, and then it's going to be flowing out. So because I'm flowing out, I'm going to subtract how much water has left. And so instead of putting t's here, we're actually going to use x's, right? The reason being is that we don't want the variable in the top to match the variable in the integral. So they've got to be different. So I'm going to use x's there, but t's in the top, okay? Okay, so this equation represents the amount of water in the pipe at any given time t. If I want to figure out is the amount of water increasing or decreasing, I want to take the derivative of this, okay? So the derivative of A is equal to, well, the derivative of 30 is 0. And then when you take the derivative of an integral, all you have to do is just plug in those t's, right? So r of t minus d of t, okay? All right, so then it wants to know at time t equals 3. So a prime of 3 is equal to r of 3 minus d of 3. So on our calculator, we're going to take y1 of 3 minus y2, whoops, getting ahead of myself, y2 of 3. And we get negative 0.314, okay? Negative 0.313, 0.314 would be fine, either one of those. Whichever one you want to, I mean, yeah. So as long as you're rounding to the third decimal place, you're going to be fine, okay? So what I would say is, let's see. I would say that the rate is decreasing. The amount of water is decreasing. Because r of 3 minus d of 3 is less than 0. Okay, and if you wanted to, you could even kind of manipulate this a little bit. You could even say that, I mean, if we change this equation around, right? If we moved the d of 3 to the other side, right? The amount that's leaving is greater than the amount that's entering. So it should make sense that we are decreasing, okay? Either way you want to say it would be fine, all right? Whichever justification there. Okay, part C. At what time t between 0 and 8 is the amount of water in the pipe at a minimum? Justify your answer. So I'm trying to find a minimum on a closed interval. What test do we need to find a minimum on a closed interval? Candidate test, right? We've seen this so many times through these free response questions. I can almost guarantee you will see a candidate test on your exam. Okay, so for part C, I'm going to take my equation, the A of t, that is going to represent the total amount of water. Okay. And then what we're going to do is we're going to set it equal, or I'm sorry, to do a candidate test, we need to figure out when is the derivative equal to 0. Oops, keeps moving on me. When is the derivative equal to 0 or undefined? The derivative, like we saw before, is just r of t minus d of t. So what we can do is if I set this equal to 0, I want to know when do these two equations equal each other, right? If I move that d of t over and make it positive, then I just want to know when do these two equations equal each other. So on my calculator, if I go to the y equals screen, they're already there, so that's good. I'm going to change my window because the interval is from 0 to 8. Let's go ahead and change this from 0 to 8. I don't know what my y values are just yet, so let's just take a look at the graph and see if they fit. If they don't fit, then I'll need to adjust them. I can see that intersection, but maybe there's something else going on over here, so I'm going to bump that y window up, the y maximum to, let's say, 20, and let's see what that looks like. Cool, so I can see the whole graph now. It only has one point of intersection here. So to find that point of intersection, I'm going to press second, trace, intersect. Y1 is my first curve, so I press enter. Y2 is my second curve, so I press enter. For the guess, we can get close, but we don't have to. Right, and the point of intersection is 3.272. Okay. So for the candidate test, I'm going to use this critical number. And remember, if we go back to our home screen, that value is stored as x. Okay, so that's going to come in handy here in just a second. If you want to, you can store that as a or any other letter that you want. As we go through the calculator, it might be beneficial not have so many x's in the problem. Okay, so for the candidate test, we're going to test the endpoints and the critical number. And what we're going to do is we're going to plug them into the equation, that represents the total amount of water. Okay, so we're going to be plugging them into A of t. Okay. So what I'm going to do is, on my calculator, I'll take 30 plus math 9. And this first one goes from 0 to 0, so you probably could already guess what's in there. But the reason I'm still typing it in is because it's going to make it easier to change the bounds on the next examples. So let's see, we had r of t minus d of t, so y1 minus y2, and then dx. Can you guess what this integral is going to be since it goes from 0 to 0? What is this expression going to equal? You get 30. Okay. And then what I'm going to do is I'm going to copy this same integral and change my top bound to a, right, which is that 3.272. So now I get 27.965. Okay, and I'm keeping track of these values on my table here. And then I'm going to copy that same equation and change the top bound now to 8. And get 48.544. Okay. So what is the smallest value, right? If I'm looking at my table, what is the smallest value? And it looks like I have a minimum of 27.965 at t equals 3.72. So let's go ahead and write this out. Minimum amount of water is 27.965 feet cubed at t equals 3.272. Okay? All right, part D. The pipe can hold 50 cubic feet of water before overflowing for t greater than 8. For t greater than 8, water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. Write but do not solve an equation involving one or more integrals that gives the time w when the pipe will begin to overflow. Okay, so I want to know when this pipe will begin to overflow. So I'm going to take, because it can hold 50, we want to know when is it going to be 50 or more, right? So we're going to take the amount, this equation, this represents the total amount, 30 plus the integral, and because I'm solving for w, the time is w, I'm going to change it from 0 to w of r of t minus d of t. And I want to know when is it going to be 50, right? When can the pipe can only hold 50, so I want to know when it is equal to that, because that will tell me when the pipe begins to overflow. So what we're going to do is we're just going to set it equal to 0. Or I'm sorry, set it equal to 50. And that's all we got to do. It just says to write an expression but do not solve. Okay? All right, let's talk about points. You're going to get 2 points on part A. 1 point for the integral, 1 point for your answer. On part B, you will get 2 points. 1 point for considering r of 3 and d of 3, and then 1 point for your answer with your reason. On part C, we're going to get 1 point for considering r of t minus d of t equaling 0. You're going to get 1 point for your answer and 1 point for your justification. Remember, the candidate test is a good justification. And then for part D, you're going to get 1 point for the integral and then 1 point for the general equation. Okay, there's your 9 points. So let me know if you have any questions about this one.